Hello, this is Mr. Best. We're going to be doing homework questions 33 to 38 in this video. The first question wants you to copy and simplify the following expressions by combining like terms. So we want to find the like terms, the ones that have the same variables with the same exponents, and add those together or subtract. So in this case, on example A, we have 4x squared, and it's the only x squared term, so that one will stay the same, so we'll do 4x squared. Then we'll look at our x's. I'm going to highlight these. We got a 2x, a little much, 2x plus 3x plus 1x, so that's a 1 in front of that x there, so 2 plus 3 plus 1 is 6x, and then the last thing we have is a plus 3 and a plus 10, so that would be plus 13. And there's example 33A. Let's do B now. I'm going to rewrite B so that all the terms are still there, but they're in the right order in terms of what we're combining. So for example, we have a 4y squared plus a y squared. So those two we can combine. We also have a 4x, a 1x, and a 3x, so we will combine those. So let's see here. We have left a 9 and a 10. So that way you can kind of get everything in order and then add those together. So 4y squared plus 1y squared is 5y squared. We then have 4x plus 1x plus 3x is 8x. And then 9 plus 10 would be 19. So that's how another way that you can write it out so that you're simplifying by getting everything together. Alright, moving on to C. So 2x squared plus 3x squared plus 4x squared is 9x squared. We then have plus x, so that's the only one of that one. And then we have the plus 30 plus 14, and so that would be plus 44. And once again, we can definitely do what I did on example B and put everything together and then combine it. Alright, on D we have, let's see, we got a 4y squared plus a 1y squared, so that's 5y squared. And we have some x's and y's here. We got plus 5xy and plus 1xy, so that would be plus 6xy. And then we have a plus 20 and a plus 10, so that would be plus 30. So that's how you can combine your like terms. Remember, a like term has the same variable with the same exponent. On 34, we're going to solve each equation, show the work, or show the check to prove your answer is correct. So we're going to solve it and then we're going to check it. 3x plus 5 minus x is equal to x minus 3. We first want to combine what we have on each side if we can. We have a 3x minus an x on the left side, and on the right side we don't have anything to combine, so this would be 2x, 3 minus 1, 2x plus 5 is equal to x minus 3. Now we can get the variable on the same side by using the inverse, so it's a positive x, I'm going to subtract x. And that is equal to negative 3. And then we subtract 5 to both sides and get x is equal to negative 8. So this is what we feel like the answer is. Now we're going to check it to verify what we did algebraically is correct. So we're going to replace all the x values with negative 8. And then simplify both sides and see if they're equivalent. So we get negative 24 plus 13, and it is plus 13 because you have minus a negative, so it would be adding, is equal to negative 11. Negative 24 plus 13 is negative 11, so negative 11 is equivalent to negative 11. So our check is correct. And so therefore our answer, x equals negative 8, is correct. For B, we have 5x minus the quantity of x plus 1. So you're subtracting that whole thing. And then 5 minus 2x. So this is like 5x minus 1, and then you distribute that negative 1 inside the parentheses. So that would be negative 1x, and then a negative 1 times a positive 1 would be a negative 1. And then you can combine your like terms. So 5x minus 1x is 4x. We want to add 2x to both sides. 6x minus 1 is equal to 5. Now we need to get the constant on the other side. So we add 1 to both sides and then divide by 6. So x is equal to 1. So once again, that's what we think our answer is. We're going to check it to see that it is correct. So down here we're going to plug in 5 times 1 minus 1 plus 1 is equal to 5 minus 2 times 1. So 5 minus 1 plus 1 is 2. And then 5 minus 2, so you can see they will be equivalent. 3 is equal to 3. So the check does work. So that's how we continue to work on solving equations. Question 35. Fisher thinks that any two lines must have a point of intersection. Is he correct? Remember, lines extend forever, so would that make sense? If so, explain how you know. If not, produce a counterexample. That is, find two lines that do not have a point of intersection and explain how you know. So when you're looking at this, all our lines extend forever. So even if you have a line like this, and then like this, do those intersect? Well, if we extend them forever, they're still going to intersect. So is there an example or a counterexample that shows that when you graph two lines, they will never intersect? All right, well, when you think about this, there are such two lines. All right, and these two lines are called parallel. They have the same slope, and even if you continue them on forever, they will never intersect. So as long as you have two parallel lines, which means they have the same slope, you have two lines that do not have a point of intersection. Question 36. Write and solve an equation for the following problem. In the last election, candidate C received 15,000 fewer votes than candidate B. If a total of 109,000 votes were cast, how many votes did candidate B receive? So we're trying to figure out how many votes candidate B received. So that's our unknown. So pick whatever variable you want. And I'll pick B. So B is equal to the number of votes for candidate B. All right. So how are we going to set up this equation? Well, since we know that B is the number of votes for candidate B, what is candidate C? Well, they received 15,000 fewer than B. So 15,000 fewer. So if B was the number of votes for candidate B, then we have 15,000 fewer would be the number of votes for candidate C. And if there's a total of 109,000, if we add these two together, B plus B minus 15,000 should equal 109,000 votes. And so now if we solve this, we can combine our like terms. So 2B is equal to 124,000. And then we divide by 2 and we get 62,000 votes. And that's 62,000 votes for candidate B. And that's what the question is asking. How many votes did candidate B receive? 62,000 votes. Make sure you answer that question. And so there you go. I do have a slight problem with this question that is being asked. It does tell you candidate B and candidate C. I'm kind of curious about candidate A. Were they in the election? What's going on there? So we kind of have to assume that I guess it's just candidate B and C that are receiving those votes. Question 37, evaluate the following expressions. So we're working with fractions again with the 4 operations: addition, subtraction, multiplication, and division. So on A, we're working with mixed numbers here. You can keep them in mixed form, or you can rewrite them in improper form. I typically write everything as in improper form. It's not right or wrong, but that's just kind of usually the way I do it. Some of these will get a little bit larger because of the mixed number, but like I said, it's kind of up to you on how you want to do that. So 10 and 7/9 would be 90, and then plus the 7, so you'd have 97 over 9 plus or minus. I'm going to change that to a minus since it's plus a negative, so minus, and then that would be 27, so what, 29 thirds? So I'd have to find a common denominator by multiplying by 3. So 97 ninths minus, and then that would be, if I did 30 times 3 would be 90, and then subtract 3, so it'd be 87 ninths. And then now you have a common denominator. You can take 97 minus 87, and that's 10 ninths. And you can leave it in that form, or if you want, you can write it back as a mixed number, which would be 1 and 1 ninth. Alright, problem B is subtraction. So once again, I'd probably rewrite them as mixed numbers. Change them from mixed numbers to improper. So B would be 10 times 10 is 100 plus 7. So that's 107 divided by 10, and then that whole fraction is a negative. Minus 5 times 2 is 10 plus 3 would be 13 fifths. And so once again, with addition and subtraction, we always need to find that common denominator. So we can leave the 107 over 10 minus, oh, I multiplied by 5. That is not correct. That would give me 25. So let's change that. We want to multiply by 2. And so it'd be minus 26 over 10. And so now it's minus negative 107 minus 26. Keep the denominator the same. So that would be negative 133. And that cannot be simplified, so you can just once again leave it in that form, or you can change it back to a mixed number, which would be what? Negative 13 and 3/10. Okay, moving on to question C. We have 4 and 1/2. Once again, I'll change that to 9/2 as a mixed improper fraction. Times 10 times 3 is 30, plus 3 is 33 over 10, but it is a negative. So we can multiply straight across, or we can cancel if any of the factors are in common between numerator and denominator. And as I'm looking, I'm not seeing anything. 9 doesn't go into 2 or 10, and 33, nothing's in common in 2 or 10. So it looks like we can just multiply straight across. 33 times 9. So we get negative 297, and then 2 times 10 is 20. And then if we wanted to rewrite that as a mixed number, that would be, let's see, so it would be negative 14. That would give you 14 times 20 is 280, and then 17 over 20. So maybe I would just leave it as the improper fraction. But once again, either one of those would work. And on D, you have negative 8 and 3/5. We have a division problem, and once again change it. So that would be negative 43 over 5 divided by 6/5. So just like I showed in the last video with division, we're going to multiply by the reciprocal, and I showed why we are able to do that. And so now we can use our multiplication and cancel common factors. So the 5's cancel. And then I think that's it for any other cancellation. So now we can just multiply straight across, and we will get negative 43 over 6, and if we want to write that as a mixed number, that would be negative 7 and 1. Negative 7 and 1/6. So those are the 4 operations. A little bit more challenging on this one than the other day just because of all the mixed numbers, but they still work the same. All right, and the last one here, find the equation on the line based on the table. So we're given 4 ordered pairs, and I'm going to write these out because I want you to see with the table that we don't make the mistake with the change of y over the change of x, because the table has x on top and y on bottom. You only need 2 points to find the slope, and that's where you need to start. So pick your 2 points. I'll just take the first 2 here. And so the change of y is 3 minus 2 over the change of x, 4 minus 2. So it looks like I get 1/2. And yet you can once again look at the table and say plus 2 for the x, plus 1 for the y, which is 1 over 2. So you can do it that way as well. Choose another point. Doesn't matter which point you choose. I'm going to do the 4, 3. So you have a point and a slope. So now remember, you can use your equation y equals mx plus b. You know the y value for that point is 3. The m, or the slope, is 1/2. The x is 4. You don't know the intercept, so that's plus b. So now you take half of 4, which is 2, and you're solving for b. Subtract 2 from both sides, you get b equals 1. So now you have the 2 things that you need, slope and the y-intercept. So your equation is y equals 1/2 x plus 1. And that's how you write the equation of a line given 2 points, or given, in this case, multiple points on a table.